Welcome to Understand the Math. In this video, I'm going to teach you how to use factoring to solve trigonometric equations and walk through 3 example problems. Before you begin, be sure to check out the video description below for a link to free guided notes that you can download and fill in as you watch this video. In the 3 example problems that we're going to solve, we will find all solutions and then we'll find solutions for theta equal to 0 up to 2 pi. The strategy that we're going to use is to factor out the common trigonometric function and then set each factored expression equal to 0. The first step is to factor out the common trigonometric function. The second step is that we're going to reduce each equation to sine theta is equal to a constant, cosine theta is equal to a constant, or tangent theta is equal to a constant. The third step is we're going to determine the quadrants for theta. In our fourth step, we're going to plot the value of sine theta, cosine theta, or tangent theta on the unit circle. And then our last step is we'll find all solutions for theta. We'll use reference angles to find these solutions, and I've included a chart here that we can use as a guide. Let's now walk through our 3 example problems. For all of these problems, we're going to find all solutions to the given equation and then find solutions in the interval from 0 up to 2 pi. Our first equation that we'll solve is 5 sine theta cosine theta minus 4 sine theta is equal to 0. Our first step is that we're going to factor out the common trigonometric expression. We notice in this equation that each term has a sine theta, so we can factor that out. We pull out sine theta, and we're left with 5 cosine theta minus 4 is equal to 0. We set both expressions equal to 0. We'll now reduce each equation to just sine theta, cosine theta, or tangent theta is equal to a constant. Our first equation is already done, so we'll just recopy that. We have sine theta is equal to 0. And for our second equation, we need to solve for cosine theta. So we'll pull the 4 to the right-hand side. This gives us 5 cosine theta is equal to 4. And then cosine theta is equal to 4/5. Our solution for our first equation is theta is equal to arc sine of 0. And our solution to our second equation is theta is equal to arc cosine of 4/5. For theta is equal to arc sine 0, our theta is going to be a coordinate point. In our second equation, because theta is positive, theta is going to be located in quadrants 1 and 4 because that's where cosine is positive. We'll now plot the value of sine theta and cosine theta on our unit circle. In our diagram on our left, we're going to plot where sine theta is equal to 0. Sine theta is equal to our y value, and that's going to be 0 at this point and at this point. This gives us that theta is going to be 0 plus 2n pi, and then theta will be pi plus 2n pi. Between 0 and up to 2 pi, this gives us values of 0 and pi. And we remind ourselves that n is 0, plus or minus 1, plus or minus 2. Let's come back now and solve our second equation. Theta is located in quadrants 1 and quadrant 4, and is equal to arc cosine of 4/5. So let's write down that theta in our first quadrant is equal to theta sub r, and it's the arc cosine of 4/5. When we throw that in our calculator in radian mode, we get a value of 0.6435. Our solution theta that's in our fourth quadrant is going to be 2 pi minus theta sub r. And when you put that in the calculator, you end up with a value of 5.6397. We can summarize our solution here. Theta is equal to 0.6435 plus 2n pi, and theta is equal to 5.6397 plus 2n pi. The values from 0 up to 2 pi are then 0.6435 and 5.6397. If you're finding this video helpful, please give it a thumbs up and consider subscribing to my channel. Our second equation to solve is 2 cosine theta sine theta minus cosine theta is equal to 0. We notice that there's a cosine common to both terms, so we'll factor that out. We have cosine theta, and we're left with a 2 sine theta minus 1 is equal to 0. That gives us the equation cosine theta is 0, and the equation 2 sine theta minus 1 is equal to 0. Let's now reduce both equations so they have just a sine or a cosine on the left-hand side. So our first equation is already in that form, so we'll just recopy it. Cosine theta is equal to 0. And our second equation, we'll go ahead and write down again. This gives us 2 sine theta is equal to 1, taking the 1 over to the right-hand side. And then sine theta is equal to 1/2. As you get used to doing these problems, you won't really have to divide it up into this many steps because you'll soon learn the flow of what you need to do. Let's make a note that our solution for our equation on the left is theta is equal to arc cosine of 0. And the equation on the right, the solution is theta is equal to arc sine of 1/2. Since cosine theta is equal to 0, theta is going to be a coordinate point. For the equation on our right-hand side, sine theta is positive, and sine is positive in quadrants 1 and 2, so theta is going to be in quadrant 1 and in quadrant 2. Cosine theta is associated with the x value, and it's going to be 0 at this point and at this point. So this tells us that theta is going to be equal to pi over 2 plus 2n pi, and it's going to equal 3 pi over 2 plus 2n pi. The values between 0 up to 2 pi are then pi over 2 and 3 pi over 2. For our equation on the right, we have theta is arcsine of 1/2. The arcsine of 1/2 is equal to pi over 6. So in our first quadrant, we'll say that theta is theta sub r, our reference angle, is pi over 6. Our theta in our second quadrant is going to be pi minus theta sub r. So this is pi minus pi over 6, which gives us a value of 5 pi over 6. So down at the bottom, we'll write that theta is equal to pi over 6 plus 2n pi and 5 pi over 6 plus 2n pi. And we'll remind ourselves that n is 0, plus or minus 1, plus or minus 2, and so forth. Hopefully by now you're starting to get the flow of these problems. The last equation that we'll solve is 3 tangent theta sine theta plus 2 tangent theta is equal to 0. We see that we have a tangent common to both terms, so we'll factor that out. This gives us tangent theta times 3 sine theta plus 2 is equal to 0. This gives us two equations. Our first equation is tangent theta is 0, and then our second equation is 3 sine theta plus 2 is equal to 0. We'll now reduce each equation so that it just has a tangent or a sine on the left-hand side. Our first equation we don't have to change. That's tangent theta is equal to 0. For our second equation, we have 3 sine theta plus 2 is equal to 0. So that gives us sine theta is minus 2/3. Since tangent theta is equal to 0, our solution theta is going to be a coordinate point. And for our second equation, sine theta is negative, so theta is going to be in quadrants 3 and 4. Let's remind ourselves that tangent theta is equal to sine theta over cosine theta. So when tangent theta is 0, that's the same when sine is equal to 0. Our sine value is associated with y, and it will be 0 at these 2 points. So we'll write down here that theta is going to be equal to 0 plus 2n pi, and then pi plus 2n pi. So our value from 0 up to 2 pi is going to be 0 and pi. And we'll put in our values for n. Let's make a note that theta is going to be arc sine of minus 2/3. So our reference angle is going to be arc sine of 2/3. And that is approximately, when you put it in your calculator, 0.7297. Our angle in our third quadrant is going to be pi plus theta sub r. Theta is approximately pi plus 0.7297, and this is approximately 3.8713. In our fourth quadrant, theta is going to be 2 pi minus theta sub r. So theta is approximately 2 pi minus 0.7297. And this gives us theta is approximately 5.5535. Our solutions for theta are then 3.8713 plus 2n pi and 5.5535 plus 2n pi. Between 0 up to 2 pi, theta is equal to 3.8713 and 5.5535. You might want to watch the next video in this series. It's on learning how to solve quadratic trigonometric equations. If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.